Hello everyone, this is me Dr. Savitha M. In continuation with my discussion on the VTU chemistry syllabus, I am now discussing on the next topic, that is the battery technology of the first module, that is electrochemistry. Um, all the videos that I have uploaded till now is under uh, and is uploaded in the channel My Intuition. You can refer to that. Kindly like and share the videos. Okay. Uh, the first part of the chemistry, that is module 1, where we have already finished all the videos. You can refer to those. The second part is energy storage system, wherein we will be discussing on some of the basic uh, concepts of batteries. Okay. The classification of batteries, all these things. Okay. So as you all know, a battery is a device which consists of many galvanic cells connected in series or parallel to give a specific output. Okay. Then these batteries are portable source of energy. They can store the chemical energy in the form of active materials, and it will on demand, whenever you want to use it, you can extract electric energy through the uh, I mean uh, by the expense of the chemical reactions. Okay, so the battery is the one which gives a specific output. Okay, and the first part is basic components of a battery. We all know the basic if you just dissect a battery, what are the basic components, what and all you can find within the battery. The first one is you can find the electrodes. Okay, anode and the cathode and the electrolyte, separator, all these you can find. Okay, let me discuss on every part separately. Okay, let us assume this is a battery. You can see this is the anode compartment, this is the cathode compartment, there is electrolyte, two compartments are there, there is a separation between the two compartments. Okay, now this is the anode which is connected to the anode terminal, and the anode electroactive mass, that means the materials which will liberate electrons. Sometimes the metal itself is taken as the anode, and it also is the electroactive material. It itself undergoes oxidation and liberates electron. Whereas in some other case, there may be a anode metal which is supported for the by which is supporting the electroactive species, that is the anode material, which will actually liberate electrons on oxidation. Okay, so that is the anode material. Now what is the anode? Anode is the one which gives out electrons by undergoing oxidation. This in detail we have discussed in the previous video, that is of the oxidation reactions. In batteries, anodes are generally chosen which are of low cost. Okay, because they do not actually take part in the reaction. It is the electroactive material which is liberating electron. And what anode electroactive material should be chosen for the anode construction or anode preparation is the material which undergoes oxidation easily. It has the capacity to deliver high coulombic output. It has good conductivity, high stability, and ease of fabrication. Easily you can fabricate the anode. Okay, so these are the requirements of the material which can be used as anode in a battery. Okay, now generally anode we are taking as zinc. Okay, and there is nowadays we can think of, we are using batteries which contains lithium as the anode material. Despite of the high cost, it is being used in batteries. Why it is used, all those things I will come in the later slides. Okay, now next basic component is the cathode. Okay, cathode and the electroactive cathode species. So same batteries. See here, this is the cathode and this is the cathode electroactive material. Okay, it is the electroactive material which will be accepting the electron. Okay, now the cathode is the one which accepts electron. There will be some metal ions in the cathode reactive material which has lower oxidation state, therefore it will accept the electron, gets reduced. Okay. And the it gets reduced. Okay, from a higher oxidation state it will get reduced to lower oxidation state. Okay, the cathode electroactive species which is chosen should have high reduction potential. That means it has should have the high ability to accept electron, therefore the reactions will be fast, and it should be highly resistant to the electrolyte, because electrolyte is also present. It should not take part in the reaction. Okay, it should not chemically react with the electrolyte, the cathode material whatever is chosen. Okay, next is the electrolyte. Anode, cathode are the electrodes. Next is electrolyte, which completes the internal circuit. See, you have the anode material, cathode material, connections are there. There is electrolyte. Okay, in the previous discussed batteries like Daniel Celler, in basic batteries, there was an anode compartment, there was a cathode compartment, both were connected by salt bridge, all these. Okay, anode had a material, metal which is dipped in its own ions. Cathode has a metal which was dipped in its own ions. The electrolyte, ions means electrolyte, those were in the solution state, and they were different compartments, and the two compartments had to be connected through a salt bridge. But nowadays you can see the batteries whatever we are using, they don't have a salt bridge. Means the same electrolyte is used. Okay, anode and the cathode compartment, the same electrolyte is used, and there is no salt bridge as such. Okay, now the electrolyte is present. So now what is an electrolyte? An electrolyte is an ionic conductor. That means it provides ions which will react at the, it will provide negative ions which first initially react in the take part in the anode reaction, produce some products, and these products will go near the cathode compartment, again produce the anode ions. Okay, that means the electrolyte completes the internal circuit, whereas the external circuit is completed by the external connections. Okay, generally chosen electrolyte is a acid, alkali, or salts have very high ionic conductivity, because they have to conduct, they should move from one electrode to other. Okay, then what material can be, what can be chosen as electrolyte? The electrolyte should be safe to handle. That means they should not undergo any what explosion, all those things. And they should be resistant to the electrode material. That means they should not react with the anode or the cathode reactive mass and reactive material. And also they should have high ionic conductivity, they should have excellent ionic conductivity. Okay, now what separator, there's another thing. You can see the basic the component, I mean the diagram of a battery. Here there is a line which is separating the anode and the cathode, and that is the separator. Okay, why a separator is used? A separator actually separates the anode and the cathode compartment, otherwise if the active mass will mix with one another. Okay, the separator electronically separates the anode and the cathode. Okay, it prevents the internal short circuiting. That means the anode reactive material is in the anode compartment, cathode reactive material is in the cathode compartment, and there are chances that the anode reactive mass and the cathode reactive mass combine there itself. Okay, in that case if it combines, we don't get any output. We want the electrons to transfer through the external circuit and come to the cathode compartment. Okay, if they combine there itself, then there will be internal short circuiting. Okay, so therefore to avoid that, it electronically separates, that is the separator separates the anode and the cathode reactive mass, so that they don't mix with one another. Okay, generally fibrous form of cellulose, cellophane, vinyl polymer membranes are used as separators. Okay, now what are the properties of the separator? Okay, the separator should be highly permeable to the ions. That means um, the anode reaction and the cathode reaction takes place, and whatever is required for the anode reaction should be provided from the electrolyte, and the products of the anode reaction also should go to the anode cathode compartment. That means the separator should allow the passage of electrolyte. Okay, it should not react with the, it should separate the anode and the cathode, but it should be permeable. That means it should be porous, and it should allow the ions to pass through it. Okay, it should have high capacity to prevent the mixing of active materials, and it should have high conductivity, but it should not be electronically active. That means it should have low electronic conductivity. It should not conduct electricity, but it should allow the ions to pass through it. Okay, it should be permeable for the ions. Okay, then high strength of flexibility, its chemical resistance to the active material. That means it should not get involved in the reaction. That means it should not react with the reactive masses, anode and the cathode reactive masses. This is a separator. Next topic we shall be discussing is classification of batteries. Now, batteries are classified as primary batteries, secondary batteries, and the third one is the reserve batteries. Let us discuss individually. Primary batteries. What are primary batteries? Batteries which cannot be reused. Once you purchase a battery, you start using it, the all the chemicals will get converted into products. We get the energy, and once all the active mass gets converted into product, you have no anode reactive mass. Everything has been connected to the converted into the products. Then you cannot use that battery again. Such a battery is called a primary battery. You just have to discard the battery when the anode reactive material gets exhausted. Such batteries are called as primary batteries. Okay? Once used, the electroactive materials gets converted into product, and this product cannot be restored back as chemicals. Okay, restored back as electroactive materials. Okay, they cannot be recharged. For example, you have zinc air battery, lithium manganese battery, or Leclanche battery, whatever you are using in the torch batteries, that is what dry cell, what we call. Okay, these are all batteries which cannot be recharged. Okay, those are primary batteries. The second one is secondary batteries, rechargeable batteries. Nowadays, whatever batteries we are using, most of it are rechargeable batteries. That means you can recharge it. That means when you are using, the chemicals get converted into products. When all the anode reactive material gets converted into products, what you can do is you can reverse back the reaction. Okay, now when you reverse back the reaction, the electroactive material will be restored back. The chemicals will be restored back. That means you have to reverse the reaction. Okay, for this reversal, we need the help of external source. When we supply the mobile batteries and all, what we are using, when you are using, chemical energy is getting converted into electrical energy. At the same time, all the anode materials gets converted into what products. Okay, once anode material gets converted into products, what you can do is you can plug in and make the reaction to go in the reverse direction. That is, the product will again be restored as um, electroactive material, that is restored as reactants. These are called rechargeable batteries. They are also called reversible batteries. Example are lithium ion batteries, whatever we are using, mobile batteries, nickel metal hydride batteries, and most of the batteries are lead acid battery. All these are rechargeable batteries. Okay, the third one is reserve batteries. Okay, as let us come back for the basic components of a battery. See, there is a battery is a package means once it is formed, the anode is there, cathode is there, electrolyte is there. Okay, the only thing remaining is the external contact, right? So the moment you complete the circuit, you get electrical energy. Okay, you can start using the battery. That means you will get the output. The battery discharges itself, right? uh, Therefore, in certain cases, what happens is, you must have observed, even if you don't use the battery at all, if you keep it inert for a long time, still, I mean, if you're not using also, there will be some loss of energy. This is because of self-discharging. Self-discharging of battery takes place because the anode, cathode, electrolyte are already in contact with one another. Sometimes uh, something in the environment may complete the circuit, and there may be a loss of some energy. Okay, so this will lead to some complication in some extreme applications, like if you are in a spacecraft and all. The people, I mean, all the energy required for the activities there will be taken in the form of batteries. Okay, now let us assume if you take a battery and start using it, and a backup is there, and the backup, if it goes to undergoes a self discharging, and by the time when we want to use it, if it doesn't have any charge, if it does not give any charge, then there will be problem, right? Therefore, to avoid this self discharging, um, there is another class of batteries which is called as reserve batteries. Okay, now reserve battery is constructed by taking uh, by constructing a battery without any one basic component of a battery, right? The basic component is anode, cathode, and electrolyte. Suppose you construct a battery without anode. What happens? Without the anode, only cathode, a single electrode, that is half cell reaction. The reaction will never take place. It will never undergo any reaction. You construct a battery without a cathode, right? Then the cell will never undergo any self discharging. But when you want to use, what you can do is you can insert the cathode. Or suppose you have taken out the anode, you can insert the anode and make the battery ready for use. Okay, such a battery where one of the basic component is kept in the reserve condition or isolated from the battery, and is inserted only when you need the battery to use, are called as reserve batteries. Okay, so what they do is, generally reserve batteries, they have electrolyte which is stored separately. Okay, or electrolyte is not present. So when the electrolyte is not present, the internal circuit will not be complete, and therefore the battery will never undergo any self discharging, right? So what usually is done is, electrolyte should be in the ionic state, should be in the solution state. So what is done is, the salt is kept inside the battery. Anode, cathode, separator, everything is there, but the electrolyte material is kept. It is not in the ionic state, right? Whenever you want to use, just add water and make it a solution. It becomes an ionic solution. It is ready for use. There are certain batteries in which the electrolyte should be in the molten state. Then all these inorganic salts are already kept in the battery, and just you have to heat it. When you heat it, it gets converted into molten state. But only in the molten state it can be used. Such batteries can be used. Okay, these are called as reserve batteries. Usually, in reserve batteries, electrolyte is stored separately or isolated, and the battery can be used only when the electrolyte is present. Okay, so this is the reserve battery, and reserve batteries are mainly designed to meet high and environment severe storage requirements. For like in space and all, we don't know what is the environment present there. Therefore, there might be a chance that batteries undergo self discharging very soon. So in that case, we need to take reserve batteries. Okay, they are primarily used to deliver high power for a relatively short period of time. Some of the examples are magnesium silver chloride battery. All these are water activated batteries. Activated batteries means you just have to add the water, prepare the electrolyte. Okay, there are also thermal activated batteries. Like I said, you just have to increase the temperature. Thermal activated, by if you just increase the temperature, it will be ready for use. Okay, so this is the classification of the battery. Now I shall be discussing on the next topic, that is some commercially used batteries, that is lithium ion batteries and cadmium batteries, lithium nickel metal hydride batteries, in my next video. uh, Thank you.